Imagine an asteroid, a single celestial body carrying trillions of dollars worth of precious metals. Yes, you heard it right, trillions of dollars, all floating in the vast expanse of space. Welcome to the future of mining, a future where our next gold rush might not be in the remote corners of our planet, but in the cold, dark void of outer space. You see, asteroids, these seemingly insignificant specks in the night sky, are actually treasure troves of resources. They're packed to the brim with everything from iron, nickel, and cobalt to incredibly valuable metals like gold, platinum, and palladium. And the cherry on top? They even contain water, a resource that could be used to sustain life or propel rockets on long space journeys. But why are we talking about asteroids? Well, because they hold the potential to revolutionize not just the mining industry, but also the way we approach space exploration and resource sustainability. They could very well be the stepping stones that allow us to venture deeper into space, setting up space stations, colonies, and even industries far from our home planet. Now, we're not just daydreaming here. Serious thought and effort are being put into making asteroid mining a reality. Companies and governments around the world are already investing in technologies to prospect and mine these celestial bodies. From robotic mining spacecraft to advanced telescopes for asteroid detection, the race is on to tap into this trillion-dollar industry. However, it's not as easy as just flying up there and starting to dig. Asteroid mining poses huge technological, logistical, and even legal challenges. But the potential rewards, they're astronomical to say the least. From solving resource scarcity on Earth to enabling us to become a multiplanetary species, the stakes are incredibly high. The prospect of mining asteroids is tantalizing, but it's not without its challenges. While the idea of extracting precious resources from these celestial bodies is fascinating, the road to achieving this goal is laden with numerous hurdles. First, let's delve into the technological challenges. Asteroid mining is not a simple task. It requires innovative technology that can withstand the harsh conditions of space. We're talking about advanced robotics capable of drilling into the solid surface of an asteroid and extracting the desired minerals. These machines must be autonomous, capable of making decisions on their own, as real-time communication between Earth and the mining site is not feasible due to the vast distances involved. Moreover, these robots must be efficient and durable. They need to extract as much material as possible in a short period to justify the enormous costs of such missions. And they must survive the harsh conditions of space, such as extreme temperatures and cosmic radiation. Developing such technology is no small feat, and we are still in the early stages of this process. The logistical challenges of asteroid mining are equally daunting. After identifying a suitable asteroid, we need to reach it. Remember, these objects are millions, if not billions, of miles away. Launching a spacecraft to such distances requires an enormous amount of fuel and time. For instance, NASA's OSIRIS-REx mission to asteroid Bennu took over 2 years to reach its destination, and that's just getting there. Once the mining process is complete, the materials need to be transported back to Earth, further adding to the logistical complexities. Additionally, there's the issue of asteroid stability. Asteroids aren't like planets or moons. They don't have a stable surface or gravity. This can make mining operations incredibly difficult and risky. Imagine trying to drill into a spinning, tumbling object in zero gravity. Not an easy task, right? Then comes the question of legal hurdles. As of now, the legal landscape surrounding space mining is murky at best. The Outer Space Treaty of 1967, which forms the basis of international space law, prohibits nations from claiming celestial bodies. But it does not explicitly address the issue of extracting resources from those bodies. So, who gets to mine asteroids and who owns the resources obtained? These are questions that we still need to answer. The United States passed the Space Act in 2015, which allows U.S. citizens to own, transport, and sell resources they extract from celestial bodies. However, this law is not universally accepted, leading to potential disputes and conflicts. To avoid this, we need an international agreement that clearly defines the rights and responsibilities of nations and companies involved in asteroid mining. Moreover, there's the ethical issue of exploiting space resources. Some argue that space should be preserved for scientific exploration and not exploited for commercial gain. Others worry about the environmental impact of space mining. Although these concerns are valid, proponents of asteroid mining argue that it could help alleviate resource scarcity on Earth and drive technological innovation. Despite these challenges, the potential rewards of asteroid mining have prompted a race for these precious resources. The idea of accessing virtually unlimited resources and the potential profits that could be made have spurred governments and private companies alike to invest in asteroid mining. While the road to achieving this goal is fraught with obstacles, the journey promises to be one of the most exciting chapters in our ongoing exploration of the cosmos. When we think of mining, we often imagine hard-hatted miners with pickaxes chiseling away at rock faces. But in the expanse of space, we must reimagine this process entirely. The technology required to mine asteroids is nothing short of groundbreaking, involving concepts that sound straight out of a science fiction novel. Asteroid mining involves several crucial steps: prospecting, extraction, processing, and finally, the return of valuable minerals to Earth. Each stage presents its own unique challenges that are being tackled with innovative solutions. Prospecting is the first step. This involves identifying asteroids rich in valuable resources. The tech used here is already familiar to us: telescopes. Ground and space-based telescopes, equipped with infrared sensors, are used to seek out potential targets. These sensors can analyze the reflected sunlight from asteroids to determine their composition. In addition, space probes equipped with spectrometers can perform flybys to gather more detailed information. Once a suitable asteroid is identified, the next step is to land and extract the resources. This is where technology becomes truly revolutionary. Robotic mining spacecraft are being developed to carry out this task. These autonomous machines, powered by solar energy or nuclear power, are designed to withstand the harsh conditions of space and work tirelessly, chipping away at the asteroid's surface. Some designs even include a drill and inject method, where water is injected into the asteroid, heated to steam, and the resulting pressure is used to extract the minerals. But extraction is only half the battle. Once the minerals are mined, they need to be processed into a useful form. In the microgravity conditions of space, this can be incredibly challenging. However, scientists are exploring technologies like microgravity foundries, where the asteroid material is heated until it melts, allowing the valuable metals to be separated out. The last step is returning the processed materials to Earth. One of the proposed methods is to use small capsules that can survive re-entry into the Earth's atmosphere, protecting the precious cargo within. Alternatively, the materials could be used in space itself, reducing the need for costly and resource-intensive launches from Earth. Many companies and space agencies are investing heavily in these technologies. For instance, NASA's OSIRIS-REx mission successfully collected a sample from the asteroid Bennu in 2020. The mission used a robotic arm to touch the asteroid's surface and collect the sample, demonstrating that such operations are indeed feasible. Private companies are also making strides in this area. Planetary Resources, a company once dedicated to asteroid mining, launched a series of test spacecraft to demonstrate technologies for prospecting and extraction. Although the company has since pivoted its focus, its pioneering efforts have paved the way for others in the field. Deep Space Industries, another private company, has plans to launch prospecting missions using small, low-cost spacecraft equipped with advanced sensing equipment. These spacecraft, known as Fireflies, are designed to make one-way trips to asteroids, collecting valuable data before ending their missions. In addition, a company called TransAstra is developing a technology known as optical mining. This involves using concentrated sunlight to heat the asteroid material, causing it to sublimate and be collected in a surrounding bag. This method could potentially be more efficient and less damaging to the asteroid than mechanical mining methods. Looking at these advancements, it's clear that the technology for asteroid mining is not just a distant dream, but a rapidly approaching reality. These technologies are not only crucial for the success of asteroid mining, but also have the potential to revolutionize other aspects of space exploration. For instance, the ability to extract and process resources in space could support the construction of space habitats, fuel depots, and even spacecraft, enabling more ambitious missions and permanent human presence in space. The field of asteroid mining is rapidly advancing, with new breakthroughs and significant missions. The race for the celestial gold rush is on, and it's not just about reaching asteroids, but about harnessing their untapped potential. Let's take a moment to shine the spotlight on some of the most significant breakthroughs and missions that are bringing this dream closer to reality. One of the most exciting advancements in recent years comes from a pioneering company named Planetary Resources. They've been working tirelessly on the development of advanced robotic spacecraft designed to prospect and mine asteroids. Their recent successful launch of the Arcade 6, a prospecting spacecraft into low Earth orbit, is a significant leap forward. This tiny spacecraft, no larger than a cereal box, has the monumental task of testing technologies that will be used in future asteroid prospecting missions. It's an incredible testament to human ingenuity and the power of miniaturization. But that's not all. Planetary Resources isn't the only player in this game. Deep Space Industries, another trailblazing company, is also making strides in asteroid mining technology. They've conceptualized a fleet of spacecraft called Prospector, designed to locate, analyze, and eventually mine asteroids. The Prospector missions, once fully realized, will be a significant step towards turning asteroid mining from a concept into a thriving industry. The advancements aren't just happening in the private sector. NASA, the world-renowned space agency, has also set its sights on asteroids. Their OSIRIS-REx mission, launched in 2016, aims to study an asteroid close up, collect a sample, and return it to Earth. This mission is not only scientifically significant, but also provides valuable insight into the logistics of asteroid mining. The successful collection of a sample from the asteroid Bennu in late 2020 is a testament to the potential of mining these celestial bodies. Across the Pacific, the Japan Aerospace Exploration Agency, or JAXA, has also been making waves with its Hayabusa missions. The Hayabusa 2, launched in 2014, successfully collected samples from the asteroid Ryugu and returned them to Earth in late 2020. The mission's success was a historic moment, demonstrating that it is possible to reach an asteroid, collect valuable materials, and return safely to Earth. But why stop at asteroids? The European Space Agency has its eyes set on a comet. Their Rosetta mission, which concluded in 2016, successfully landed a probe on a comet and collected valuable data. While it's not asteroid mining per se, it's a shining example of what we can achieve and the kind of technologies we'll need to develop to mine asteroids successfully. These missions and advancements are more than just scientific endeavors. They are stepping stones towards a future where resources from asteroids could fuel our insatiable demand for materials. They are a testament to human ambition and our never-ending quest to push boundaries. However, it's not just about the technology. Legal frameworks are also evolving to support asteroid mining. As we mentioned earlier in our video, the United States passed the U.S. Commercial Space Launch Competitiveness Act in 2015, which allows U.S. citizens to own any asteroid resources they obtain. It's a significant legal breakthrough that paves the way for the development of a space resource economy. In short, the field of asteroid mining is undergoing a rapid transformation. What was once a concept confined to the realm of science fiction is becoming more tangible with each passing year. The technological breakthroughs, the successful missions, the legal advancements, they all suggest that the dream of asteroid mining is not as far-fetched as it once seemed. The age of asteroid mining is upon us. It's a time of discovery, of pushing the boundaries of what's possible. It's a time of looking to the stars, not just for inspiration, but for resources. It's a time of dreaming big and taking those first tentative steps towards a future where the resources of our solar system are at our disposal. With every new breakthrough, the dream of asteroid mining becomes more of a reality. The celestial gold rush is just beginning. And as we continue to develop and refine the technologies, overcome the challenges, and push the boundaries of what's possible, who knows what the future holds? The sky is no longer the limit. The economic potential of asteroid mining is vast, with implications for space exploration and resource sustainability. Imagine a future where scarcity of resources is outdated, where the vast reaches of space provide us with the materials we need to fuel our economies and sustain our planet. This isn't just a science fiction fantasy, but a very real prospect that could be within our grasp in the not-too-distant future. And it all hinges on the potential of asteroid mining. A single asteroid can contain trillions of dollars worth of minerals. We're talking about vast amounts of precious metals like gold and platinum, as well as other valuable resources like water and rare earth elements. These are the kinds of materials that are vital for our technology-driven society, and they're becoming increasingly scarce on Earth. The economic potential of asteroid mining is truly staggering. We're talking about a potential trillion-dollar industry that could completely revolutionize how we think about resources. But it's not just about the money. The true value of asteroid mining lies in its potential to provide us with the resources we need to explore the universe and to ensure the sustainability of our own planet. Let's start by looking at space exploration. One of the biggest challenges of sending humans to other planets or even further into space is the sheer number of resources required. Long-term missions require vast amounts of fuel, water, and other supplies. But what if we could obtain these resources directly from space itself? This is where asteroid mining comes in. By extracting water from asteroids, for example, we could use it to produce rocket fuel directly in space. This would drastically reduce the cost of space travel, making long-term missions and colonization efforts far more feasible. It would also reduce the environmental impact of space travel, as we wouldn't need to launch all these resources from Earth. But the implications don't stop at space exploration. Asteroid mining could also play a crucial role in resource sustainability on Earth. As our planet's resources become more and more strained, we're going to need new sources of vital materials. We're already seeing the effects of resource scarcity in many areas. For example, rare earth elements, which are vital for many technologies, are becoming increasingly difficult to obtain. The extraction of these elements on Earth is also associated with significant environmental damage. But asteroids could provide us with a new sustainable source of these precious resources. The technology needed to achieve all this is already being developed. Companies and space agencies around the world are working on robotic mining spacecraft and prospecting missions, and we've already seen some significant breakthroughs. Just recently, a mission successfully returned samples from an asteroid for the first time. This was a huge step forward, proving that it's possible to reach an asteroid and extract its resources. And this is just the beginning. As technology continues to advance, the prospect of asteroid mining is becoming more and more feasible. Of course, there are still many challenges to overcome. Technological hurdles, logistical issues, and legal questions all need to be addressed. But the potential rewards are so vast that these challenges are unlikely to deter the pioneers in this field. The future of asteroid mining looks bright. The economic potential is vast, and the implications for space exploration and resource sustainability are profound. As we continue to push the boundaries of what's possible, we may find that our future lies not just in exploring space, but in harnessing its resources. As we look to the stars, we may find that our future lies not just in exploring space, but in harnessing its resources. The race for asteroid mining is on, with the potential to revolutionize our relationship with space. We've taken a deep dive into a trillion-dollar industry that's still in its nascent stages but holds the promise of an almost inconceivable wealth of resources. The silent, barren rocks that orbit our sun, it turns out, could be the answer to a resource crunch here on Earth. Think about it. Single asteroids loaded with trillions of dollars worth of minerals like platinum, iron, and nickel. But it's not just about the money, it's about securing our future, about ensuring resource sustainability as we continue to consume and expand. Asteroid mining could very well be the key to unlocking the next stage of human development, both on Earth and beyond. Of course, the road to this future is filled with challenges. We've discussed the technological hurdles in designing spacecraft that can withstand the harsh conditions of space, which can extract and process these resources millions of miles away from home. We've touched on the logistical issues, the monumental task of not just getting to these asteroids, but also returning with the bounty. And let's not forget the legal conundrums, the yet undefined rules of ownership and exploitation in the final frontier. But the wheels are in motion. We've seen the strides being made in the field, the robotic miners being developed, the prospecting missions being planned. We've highlighted a recent breakthrough that underscored the growing importance of asteroid mining. The momentum is building, the race is heating up, and we get to witness it all. The potential of asteroid mining is vast, overwhelming even. It will transform space exploration, redefine resource management, and possibly even alter the very fabric of our economy. It's a brave new world out there, and we're just getting started. Thank you for joining Time Pilgrimage on this journey through the fascinating world of asteroid mining. Remember to subscribe, like, and comment, and let us know what other topics you'd like to explore. Until next time, keep looking up.